Well, hello, ladies and gentlemen. It's Mrs. Slater. We are going to be looking at chemical reactions, and I did a little bit of a review on what happens in a chemical reaction, but today we are going to be looking at the types of reactions. So I'm going to move myself down there. And yep, there's 5 different types that we're going to be focusing on, and we are just going to be kind of going through each one. My hope is that I can also make a little video of me doing some of these reactions with my kiddos. So bring it a little bit more life than normal. So there's 5 main types. This is something if you're planning on going on in education, so going to university or college, these are going to be things that you're going to want to know for sure. But some of them are just fun to know anyways. These are the names, and of course they're all fancy because they're all science words. So we've got synthesis, decomposition, single replacement, sometimes we call it displacement, double replacement, and the fun one, combustion. So for combustion, here we go. We've got 2 things, and they're going to come together to form one thing. So that would be like, I know these are backwards, but substance A and substance B coming together to form substance AB. And notice that they're oppositely charged, so they're going to be attracted to each other. So if you look at the equations that are up, or the reactions that are on the screen, you're going to see that sodium, which is a metal, it's a really cool metal. It looks just like a silvery metal, but it cuts like butter. It feels really weird, and it's really cool. And it reacts with water, but that's another type of reaction. Anyways, you can take that, and it can react with this substance right here, which is chlorine gas, which is actually a toxic gas that if we breathe it, it could kill us. So you take this soft metal, and it can react with a toxic non-metal gas, and it makes something that we can consume on our food. And if it's like my son, he just likes it on its own. He loves salt. So anyway, this is called synthesis. It's a fancy way of saying making something. You're going to notice that 2 things are all going to become one final product. So in each of these, we're going to have just one thing on the right-hand side of the equation. This is what I was talking to you about, they used a different element in this. So you're going to notice in the bottom of the beaker, there's kind of that silvery metal there, which is potassium. And then chlorine gas, it's a pretty gross looking gas, something that you'd probably hopefully go away from it if you saw it, but it's kind of this orangish, yellowish. And then they come together, and you're going to notice that there's that repeating pattern of chlorines and potassiums, and that is a salt that's going to be pretty similar to sodium chloride. All right, decomposition. When you hear the word decomposition, what do you think about? Oh, yeah, I'm thinking about dead stuff breaking down. It's, again, just a fancy way of saying that stuff breaks down. So you're going to notice that, again, all of these kind of have a general way of working. And for all of these, they start with one reactant, and excuse me, they're going to break down into at least 2. Sometimes it can be more. I don't have any of those examples up here, but a lot of these are going to be breaking down into smaller, simpler substances. This first one up here is one I want to do with my kiddos, but carbonic acid is actually what makes fizzy drinks fizzy. So it's the source of carbonation. All right, so for that one, I'm actually going to go back to this one. So this would be kind of the opposite, whereas on the first one, the synthesis, we took substance A by itself, substance B by itself, and then they combined to make substance AB. Decomposition is the exact opposite. So we would start with this substance right here, where these 2 things are combined, and they would break down and split apart so that now you've got this thing by itself and this thing by itself. Okay, single replacement and double replacement are really entertaining to talk about, actually, because I think of high school relationships. I don't know if you've noticed, but a lot of high school relationships don't stay around for a long time. Um, so I'm going to be kind of using that example as well as my lovely little homemade cards that I've got here. But with these ones, there's kind of a trade that takes place. So if we look at this substance, let's pretend like this is an ionic substance. Think of it as kind of a couple. So you have this couple that's together, and then you've got an individual that's over here all by itself. This individual is lonely, and in the chemical reaction, again, what I want for you to remember is that all that happens is things rearrange. So when we're looking at our couple here and our individual, what's going to end up happening is, again, the wonderful world of high school relationships. This couple is going to sadly break up because they've been together for a week and a half, which is like 15 years in adult years. And so now they're no longer together. And substance C over here, which was alone, is actually going to be attracted to the negatively charged one that I have down here. So sorry, A, you're going to be all by yourself. So these two now, so the positive and the negative are going to be attracted to each other. They're going to make a new couple, and poor little A over here is all alone. Maybe they're happy about that. I hope so. So that is what we call a single replacement. We know single replacements because there's always going to be a lonely little individual that's all by itself. And that, when we look at real reactions up on the screen, it's always going to be just a single pure element. So you're going to notice in this one right here, we've got pure zinc. In this one down here, it's pure bromine. Down here, we've got silver. Down here, it's iron. And on each side, you're going to see a single element. So magnesium and zinc in that one. And then there's the couple right here, which is an ionic compound. So you've got your zinc nitrate here and your magnesium nitrate over here. And again, they're just, the couple breaks up, and then one of the individuals from the couple pairs up with the one that had been by itself. All right. So single replacement reactions, kind of fun. My stuff is totally in the way here. But here you're going to notice that lithium can actually react in water. I told you earlier about sodium. So sodium metal, lithium metal, potassium metal, they're all really soft and fairly reactive metals, because if you remember way back when we talked about types of substances, they're all alkali metals, which are pretty reactive. So if you just drop a chunk of one of those metals into water, it reacts with the water, which we normally don't think of things reacting in water. But it undergoes a reaction, and then over here, it makes a substance called lithium hydroxide, and then hydrogen gas is also going to be released. So that's the pure element on this side, whereas we started out with the pure element being lithium. All right, double replacement is where we've got two couples. So we're going to go back to my little cards here, and we've got our first couple, which is substance AB. And let's see if I can do this, and if you can actually see this stuff on the screen. I know they're backwards. I don't really know how to fix that, but we've got substance AB, which is our first couple. We've got substance CD, which is our second couple. And in the reaction, again, these are just going to rearrange. So wonderful world of high school relationships. Both couples break up. A little bit weird, but not unheard of. Our first substance from our first couple, this is the first breakup, is going to be, because it's a positive charge, cation ions, remember, are positive, is going to be attracted to the negatively charged one of the other couple. So this is going to be one of our new couples, where A goes with D. I'm going to put that one down for a second. And then B from our first couple that just broke up, and C from our second couple that just broke up. These two, you're going to notice that they have opposite charges. I always put the positive one first. So C and B are going to go together, and A and D are going to go together. So again, they just rearranged what they were hanging out with, but it's like the couples split up and then they're just repairing who they are with. So double replacements, and you're going to notice up here, they kind of look a little bit confusing, but what we're typically going to notice with the double replacement reactions is we're going to have all of our substances are compounds, and there's going to be 2 on each side. So this is a compound, which is just more than one element. That's a compound. Oh, that's missing a subscript of a 2. I'm going to go fix that later on, but that should be CaCl2. Sorry about that. And then that makes a compound and another compound, and they're just rearranging what ion they're hanging out with. So that's it for the double replacement reactions. Over here, here's kind of a little set of images. You all know I'm a very visual learner. So for single, you've got up here A and B. They're going to be our couple that breaks up in a moment. C by itself, and then over here, what ends up happening is A hooks up with C, and then now B is by itself at the end. And then for double replacement, I just did that one where our original couple breaks up, our second original couple breaks up, and they just rearrange who they're hanging out with. All right, and then there's an overview kind of all 4 types of reactions that we've talked about up to this point. Next one is the one that people like because it's combustion. And the first thing when we get into chemistry that everybody always talks about is explosions and fire and all of that cool stuff, which it is really cool. But the fancy word for that is combustion. And it's essentially when we've got fuel, what does fire have to have? I know it's up on the screen. That's right. In order for a fire to burn, we need to have something to burn. So I'm not going to actually burn these, but paper would be an okay source of energy. So this could be my fuel source. And then I would have to have oxygen, which I have oxygen in the air around here. And then if I burn that, so I would have to actually have a little spark. And if I have enough oxygen, then this thing is going to burn. And the products that get made, we usually don't think about that. We usually think, ooh, it's hot and we can see the light and the fire and all of that cool stuff. But there are actual substances that are made as a result of it. One of them is carbon dioxide. And then the other one is water. So again, I'm hoping to make another video showing you real life examples of each of these, including this. And most people don't think of fire making water because we use fire to put out. What did I just say? We use water to put fires out. That's what I meant to say. But water is actually a product of fire because the flame is so hot, it's usually water vapor. But I'll show you guys a little kind of fun thing about the combustion reactions when I do that little video for you with the demos. All right, so combustion. Yep, it's just we need oxygen, we need fuel, and then we need some sort of spark to get that reaction going. Earlier in the year, remember when we got to use the Bunsen burners and make some really pretty colors of fire? Because different metals burn different colors. So that kind of gets into a different component of combustion reactions. And then again, what's nice about this, so fuel, a lot of times is going to be made of carbon and hydrogen. Sometimes there's oxygen in there as well. But when it mixes with oxygen, the products are really easy to figure out because it's always carbon dioxide and water. So for these ones right here, it doesn't matter that the number of carbons and hydrogens is different than what it was up here. We're still going to make carbon dioxide and water as our products. Always, always for combustion. We're going to get into what those little numbers mean
It's time for
later.
intervention.
Oh, we have a schedule for our kiddos, and that's our next part of the schedule. All right, and then, yeah, don't worry about those numbers. They're crazy right now. So anyway, here's the big summary of what I just went over. But again, 5 main types. S for synthesis, which is the 2 separate elements combining to form one thing. The decomposition, which is 2 substances, and then they break down into simpler substances. Single replacement, you've got your couple and your lone individual, and then they break up, and now this one comes over here and this one over here is lonely. Double replacement, the couples that started out broke up and now they're swapping who they're with. And then combustion, we take fuel with oxygen and it gives us carbon dioxide and water. So there is the overall summary. And I hope you enjoyed this and learned something new, or it helped you to understand something a little bit better than before. So later on, I'll do some more stuff, but for now, this is where we're at. All right, and I'm going to stop the share, come back here. And all right, well, that's it for the 5 types of reactions. Check back for when we make that video with my kiddos showing examples of, maybe not all of them, but a lot of them. So you guys take care. I miss you, and I will see you soon.